question says that read each statement below carefully and state with reasons if it is true or false. The first is magnitude of a vector is always a scalar. So we first look at the magnitude, how it is calculated. So let's assume that there is a vector A with 2 I cap plus 3 j cap, where I cap and j cap is the unit vector along x-axis and y-axis. So the magnitude of vector would be 2 square plus 3 square. So it is always a scalar quantity, so it is true. Now each component of a vector is always a scalar. So when we see this vector, we see that it comprises of two components, component x component and component y component. So each component is an independent vector, which is 2 I cap and 3 j cap. So this statement is false because it is never a scalar. The magnitude of each component of a vector may be scalar, but not the component of a vector is a scalar. So this statement is false. Now in third option we have the total path length is always equal to the magnitude of the displacement vector of a particle. So total path length, here it is being talked about, is equal to the magnitude of displacement vector of a particle. So when we see the movement of a particle, let us assume that this is x direction, this is y direction, and particle started from the origin and it goes in this way and it reaches here. It started from point A and reached till point B. Now when we see displacement, so we have to compare the magnitude of displacement with the displacement vector here. So displacement is defined as the difference in the position vector of initial and final. So displacement vector would be vector B minus vector A. So assuming that B is the position vector at particle at point B and A is the position vector of particle at point A. Now the path length is the addition of it is the total length of the path that the body travels in the trajectory from position A to B. So from the definition we also know that displacement is the shortest distance between the initial and final points. So since the definition always contain so when the particle is moving in not in a straight line from point A to B, it is always going to have a larger path length. So path length is always going to be greater than the displacement, greater than or equal to. Now the equality sign will only hold if the particle is traveling in a straight line, and also in the same and the particle doesn't change any direction. So this statement is false. Now in fourth option we have average speed of a particle defined as total path length divided by the time taken to cover the path is either greater than or equal to the magnitude of average velocity of the particle over the same interval of time. So the definition of average speed is path length divided by time, total time taken, and the average and the definition of average magnitude of average velocity is also the total displacement divided by time taken. So we from this relation we always see that since path length is always greater than that of the displacement, so the average speed of a particle is either always greater than or equal to the magnitude of average velocity. So this statement is going to be true. Now in the fifth option we have three vectors not lying in a plane can never add up to give a null vector. So from vector law of addition we know that, let's assume that there are two vectors, vector A and vector B. Now when we add these two vectors we will assume that vector B is here. So C is going to be the resultant vector or R is going to be the resultant vector. Now this addition of vector, this addition of vector, this three set of vectors a, b and r, if it has to be 0, then the direction of r must be from point b to point a, since r is resultant of the vector addition of a and b. So if we have to make this whole summation of three vectors to equal to 0, so we need to have minus r, and that too will only be possible if all three vectors are lying in the same plane. So in the present case we have a vector plus b vector equal to r vector. So if we have to make this three set of vector equal to 0, so we will add a vector plus b vector minus r vector equal to r vector minus r vector. So this will cancel out to be 0, and this set will have 0 value. So in order for this to be valid, all these three vectors must be in the same plane. That's how the triangle law will make them 0. So the statement that three vector not lying in a plane can never add up to give a null vector is correct, because if they are not lying in the same plane, then they can never be added up to 0. Thank you. So this is true statement.